Welcome, everyone. Thank you for joining us today. Apologies for the delay. We had some technical issues, but we got everything worked out. So thank you for holding on tight while we get that sorted out. Today, I just wanted to welcome everybody to our webinar. And I see some people are still coming in, so please come on in and join us. Our webinar is Edible Science Experiments for Some Summer Fun. And I'm Shirley Miller, a team member at the Homeschool Buyers Club, and I'd like to welcome our webinar host, Esther Novis. Esther is the creator of the Young Scientist Club, and Esther has 5 children and started the Young Scientist Club back in 1999, looking for activities for her children and as a way to put her science degree from Harvard University to good use. So before I hand things over to Esther, I just wanted to point out a few housekeeping points. So the edible experiments video today is pre-recorded. You'll see Esther demonstrate the experiments as well today. And we will have plenty of time for questions. So be sure to use the Q&A box in your Zoom, just right below. You can feel free to put your questions there. And, if Esther asks any questions during the webinar, you can write your answers in the chat box as well. Esther, did you want to say anything before we start the video on the edible experiments?
No, just, it probably will go a little bit faster than for you to participate as we're going along, but these are a lot of fun. We use those in our camps for many years, and I hope you enjoy them.
Okay.
And we will get you a printable PDF afterwards as well, so no need to take notes.
Yes, right. After the webinar, we will be sending up a follow-up email, which will include the PDF, and that will be the instructions and letting you know. And I think there's additional 2 experiments too, as well, right? In addition to that. So
correct. Yeah.
Yes. So that will be in the email. So we will go ahead and get started on the video. So let me share my screen 1 second. And we have some people that are very excited. So be sure to put your questions in the Q&A and let us know what you think as we're going. We'll play the video, and then at the end, we'll have Esther answer any questions that you guys have. So 1 second.
Hi there. I'm so excited that you guys are joining me today. I've been running a summer camp for the past 20 years for the Young Scientist Club, and this is the first year that we're not having camp. So I'm so excited you will be our campers today. Our campers in all those 20 years used to come with great ideas for new science kits, and then they would test out all the experiments. Today's theme was one of their favorite topics because all the science experiments that they would do, they could actually eat. And after I finish you doing 4 of the experiments, we will be emailing you the instructions as well. So you can do these experiments at home. You will get a PDF with 6 experiments. 4 of the experiments we'll be doing today. 2 of them you can still do at home as well, in addition to the 4 experiments we're doing today. Are you ready? So the first thing we're going to do today is make ice cream. And who does not love ice cream? So what we're going to be doing for the ice cream, you need a small Ziploc bag, a wide Ziploc bag. We are going to add the ingredients for the ice cream into this small Ziploc bag. We're going to need 2 tablespoons of sugar. We're going to need 4 tablespoons of milk. Now you can make a big amount, so you can double the amount, of course, also. So that's 4. Then we're going to add 4 tablespoons of heavy whipping cream. That's 4. And then we're going to add 2 tablespoons of vanilla, just to give it a little bit more sweetness. And obviously, we're making vanilla ice cream. Now, if you have some different flavors at home, you can certainly add them as well. All right, then when I'm done with that, I'm going to close this. Make sure it's closed very well. Then I'm going to take a large Ziploc bag, and I'm going to add 2 cups of ice. And then I'm going to add 6 tablespoons of salt. Now you might be wondering, why am I adding salt to the ice? Now salt, just like when people use salt on the ice in the winter, it actually lowers the freezing point of the ice, of water. So we're gonna put that in, mix it up a little bit, and then we're gonna put in these ingredients right in here. Make sure it's kind of surrounded by the ice. Now the ingredients of the ice cream freeze at a colder temperature than water is frozen. And that's why we add the salt, to lower that freezing point. And then you're just gonna hold it like this, rock it for about 15 minutes. Make sure that it gets cold, because your ice cream only forms if it gets frozen, if it's cold. Now this is going to be very cold, so if you're going to touch it, you might want to wear some gloves. But you're just going to keep shaking it just like this until it becomes a solid. Now I've already made a batch just to show you so that we don't have to wait 15 minutes. So I'm going to take it out. It's a little bit softer because it's so hot outside. And then we have the ice cream that you can then put in a cup. And then you can eat it. And it's yummy ice cream. So enjoy making your ice cream. You can make small batches, large batches, whatever you want.
We might have a audio, 1 second. Let's see.
And then you're just going to churn it. You're going to shake it.
I think the audio went out in that particular section. It should be on right now.
And then you're just going to churn it. You're going to shake it. You're going to shake it and shake it until you get 2 layers in your little jar. And these 2 layers, and I actually made one already for you. The 2 layers are a liquid. I'm going to pour some right here. Now that liquid is actually buttermilk. And then the solid that's in there, look at this, is your butter. And look, and then you put it on toast or whatever else you want to put on it, and then you eat it. Now this butter that we made, and I'm still making in this jar, is unsalted butter. If you want to add salt, you need to add it to the cream before you start mixing it up, before you start shaking it. Now, once your butter is finished, you can either take it out and make a ball out of it by holding it under cold water. You can either add some honey or herbs, whatever you would like. You can make your favorite butter. And then it should last about 10 days in the refrigerator. Then if the buttermilk, you can certainly taste it if it's something you'd like to drink, but that might not be as good. And the reason all we need to do is churn it and make butter by shaking it is because in the heavy cream, there's a lot of fat. And by shaking it, you're breaking all these tiny little membranes that are around these fat droplets. Once those are all broken, the fat droplets then stick to each other and they make this big solid ball of butter. And that's what your butter is. So hopefully you'll have fun making some butter at home. The next experiment we're going to do, now in the little booklet you're going to get, it's called dancing pasta. I'm actually going to make some dancing raisins and craisins instead. They seem to work a little bit quicker than doing pasta, so it's a little bit easier for when we do a demonstration. So you get a cup with water, about 3/4 full, and then I'm going to add about 2 tablespoons. We'll start with that. You can always add some more of baking soda. So we're going to mix it up. You put it here so you can see it better. We're going to mix it up so that the water gets a little bit clearer. I'm going to add some more. Okay, so we're mixing baking soda and water. Right now it looks a little bit cloudy. Let's see. That's a little bit clearer soon, once it settles down. Now, with this kind of experiment, we're going to mix baking soda, and then we're also going to add vinegar. When you mix baking soda and vinegar, which baking soda is a base, vinegar is an acid. When you mix a base and an acid, carbon dioxide is formed. Carbon dioxide is a gas, which are bubbles. And gases, when they're in a liquid, like a water, they will go up because they're lighter than air. And then when they get to the surface of the water, they pop and disappear in the air. Now, when we add something very light to that solution, see, this is a little bit. When we add raisins to that solution, or craisins, whatever, or you can use spaghetti. Sometimes rice will work as well. They will sink because they're heavy. See, and they're at the bottom of the cup. Now, when I add, so we don't have bubbles yet because all I've added to the water is the baking soda. When I add vinegar, and let's see if you see anything happen. See all the bubbles? Now keep your eye on those raisins or craisins. Okay, the bubbles are going to attach to them at the bottom. I'm going to add some more vinegar. Make sure. Got a really good reaction. So the bubbles that are formed attach to the raisins or craisins, whatever you use, and then they go up and they take them with them. Once they get to the surface, those bubbles disappear into the air, and the raisins or craisins go back down because they're heavier than water. Once they're back down, they can pick up some more bubbles, and then they go back up. And that will continue as long as there is enough bubbles in the solution. Now, you can even try this with seltzer water, or you can always, like, if it's not working, in a while when there's not enough bubbles anymore, you can add some more vinegar, you can add some more baking soda, and kind of keep playing around with it. So these are the called dancing raisins, or dancing craisins, or you can certainly try some other things, little pieces of pasta, little pieces of rice, and see, they're going up and down. So when they go down, they pick up bubbles. The bubbles make them lighter and they go up. And then when they go to top, the craisins don't actually get lighter, but because the bubbles go up because they're lighter, they take the craisins with them. Then the bubbles pop into the air and the craisins go back down. It's kind of fun to watch, right? And I can certainly keep adding more vinegar. See how many bubbles I'm making now? You'll have a lot of fun with this one. Our campus certainly always did. All right, now our last experiment, now this was always a hit. Now when we did camp, I always had lots of high school students as well as college students help out. And they had as much fun as all our campers. So I'll bet you that your parents are going to have as much fun doing these science experiments as you will. It's a great family afternoon of science fun. So what I'm going to make today is make some chocolate slime. So all we need is cornstarch. I'm going to put a cup of cornstarch in here. We need a cup of water. Put that in there. And then I'm going to just mix it together with my hand. This actually makes your hands nice and soft too, if you keep doing this. Now, what's really cool about this slime, it's actually a non-Newtonian fluid. If I grab it, it's a solid. But then, if I let it go, it turns into a liquid. So it has both properties of a solid. A solid is something hard that doesn't flow, and a liquid that does flow. So if I take a chunk, I put it in my hands, and then look, it flows all the way down. Now, if this is not totally working for you yet, if it's too dry, add some water. And if it's too hard, too soft, add some more cornstarch. You can play around with it a little bit. You can make big batches, small batches. You can add some food coloring, but it's so much fun to play around with. Now, cornstarch, it is an edible experiment because you can eat it, but cornstarch probably doesn't taste that great. Now, what we like to do, we like to add some chocolate syrup. So we're making chocolate slime here. All right, we add some more. And we're gonna mix in the chocolate and make some really good smelling chocolate slime. Now, because I added the chocolate, it became a little bit more slimy and gooey. Now, I don't want it back to, that I can grab it and it's a solid. All I need to do is add some more cornstarch. But even playing with it like this is a lot of fun. Now, sometimes what our campers used to like to do is even drop it on the table. And so they would make a big mess, but it was always fun for them to play around with it. See how easy it is to pick it up? It's very easy. You can grab it, poke it, and put it back in your bowl if you want. Certainly a good experiment to do outside. And again, look at my chocolate slime. Isn't that fun? So that is it for the 4 experiments that we're covering today. We certainly hope you had a ton of fun. And I encourage you to always do lots of science experiments. I started this company, like I said, 20 years ago with my kids, and all my kids are all grown up and they have really fun and great jobs in the science fields. And they love learning, and they just, now they do grown-up science experiments. So we hope that you get inspired by doing lots of science. And if you have any questions, let us know. And I encourage you to go to our website, youngscientistsclub.com. We have a clubhouse there with lots of fun, great information. We even have a math fact creator, so you can do lots of math problems at home. It is summer, but it's always fun to keep on learning.
Okay. All right. So I hope you enjoyed. Apologies for the video if it was a little bit unclear or there were some moments of silence. But that was our video with Esther demonstrating the 4 science experiments. And all of those experiments are great, Esther, especially for the summertime. And you just have, a sunny day, and it's, great to kind of learn about science outside and really, perform all those experiments and learn about science. So that's really fun. Did you want to add anything to the video that we just had?
No, just that, I strongly encourage kids to and families to make science fun. And, I made it fun by originally adding all the neighborhood kids, and that turned basically in a camp, and then a camp turned into a company. Yeah. And we did that for many years. But, I think it's always, great to, especially in the summer, to add friends to the fun and go outside and do all kinds of fun science, whether it's exploding volcanoes or whatever. The kids usually will let you know what they want to do and what they enjoy.
Right.
I do encourage, start early and do it a lot, but make it fun, especially at younger ages. I think starting at a very young age, at like 4 or 5 years old, and no books or textbooks are necessarily needed. They should just have fun memories with science. And I think then it just develops on its own. And there's so many fun STEM careers available. And I encourage everybody to share that with their children as well. I mean, there's anything from building bridges, civil engineers, to electricians, to nurses, doctors, paleontologists. There's just so many fun careers. And I think a lot of these kids are not even aware of. And I think having a fun and interest in science and a science background just gives children, when they get older, a lot of options in what they want to do when they grow up. So
right. Yeah,
those are my thoughts.
I agree with you. I have a young son, he's 4, and he's very much into hands-on experiments and, just trying to figure out how things work. So we definitely like STEM activities. So that's great.
Oh,
Yeah.
good. Yeah. I mean, and to keep it easy, when things get complicated and no one wants to do it. So,
Yeah.
and in the summer, it's great because you can do all the messy activities and experiments outside, and you don't
Yeah.
have to worry about your house and having to do all the cleanups, and then the kids have fun, and then you just hose them down at the end. That's what we used to do in camp.
Right.
So,
Let's see. So just if you guys have any questions, be sure to put them in the Q&A box. We have two. Someone asked, I think it was referring to your first experiment, but they were asking why do you need a big amount, but they didn't specify.
a big amount,
Yeah, I believe it was your first experiment that you had.
a big amount of.
They didn't
No,
say.
so that was making ice cream. So the ingredients, quantities that I used in the experiments just gave a little bit of ice cream. So you can make a lot more ice cream if you have more children, or if you want to just make one large batch, you just increase the ingredients, in the proportion that was given with the original recipe. So
Mhm.
you can double it, you can triple it, or however you want to do it.
Okay, great. And
Actually,
then,
used to be a really fun item on the market. I don't know if it's still there, but it was actually an ice cream ball. And you put all the ingredients in the ball,
oh,
and the kids would
yeah,
throw the ball to one another instead of shaking the bag. And
right.
that's how you would make ice cream. And that was always a lot of fun to do as well.
Yeah, that sounds fun. I think I remember that. I wonder if they still have that.
I don't know. I don't know. I haven't seen, but my kids are older, so I'm not looking for it either.
And then somebody asked, can you eat cornstarch raw? I think you said it didn't taste very well, right?
Yeah, I mean, cornstarch, you could, it's just, I mean, people put it in their dishes, they cook with it, but I don't think kids particularly like it, but it makes it a safe, a safe ingredient to work with and play with, especially when you play with young kids. I mean, I wouldn't sit there and say, oh, eat it all up, but but it's a good way to do an activity without having to worry about other kinds of slime where you add glue and other things, right? Because especially when you have, maybe you're doing this with a 4-year-old, but you have a 2-year-old sitting next to you, and then you don't have to worry about the 2-year-old putting the wrong things in their mouth if by accident they do grab something.
Right.
So that's why we don't suggest that you eat it raw, but it's not, it's much safer than glue and slime or the other, kind of things that are available in the market.
Right. Yeah. What age range would you say these are experiments would be best for?
Well, as long as there's parental supervision, you can start this as young as 4, even 3-year-olds. We started a lot of our science kits at age 3. Then we had other ones at 5. Actually, our original food science kit was for 3-year-olds, with the understanding that adults help with them. And different 3-year-olds will get different, and at any age, actually, will get something different out of each science kit. There's 5-year-olds that can read, and they understand something a little bit more different. Then you have other 5-year-olds that just want to play, but even when they're playing, it's amazing how much they will learn still and remember. And I used to see that in camp, because a lot of times in camp the kids had so much fun, but half the time I wasn't sure if they were learning. But then the parents would always come back, oh, they had all these stories at home and they remembered this, they remembered that. So that was always good to know.
Mhm.
It might not come out during the activity itself, but you'll be surprised that a week later they're telling grandma and grandpa what they did last week and what they learned, and you didn't
Right.
even know they actually learned anything. So we do give, with all our experiments, we also give the information, the science behind it, and sometimes the parents get excited because they're learning something, and that's always in the back of my mind too when I give these explanations, because a lot of times parents don't know what's happening, and so
True.
in the process, everybody is learning, and parents will learn a little bit more in the detail than maybe a 3 or 5-year-old, but that's okay because everybody learns and is having fun.
Yes, I agree.
At the younger age, it's really of making positive connections, positive memories and fun memories of what they used to do in a fun environment.
Yeah, definitely agree. Okay, I think Yeah, if you guys have any more questions, put them in the Q&A. I just wanted to let you guys know that we are having a closeout sale for the Young Scientist Club. It's basically 1 year in one box. So you get 12 science kits delivered to you in one shipping. And the closeout price is $39. It's free shipping, or it includes free shipping as well. And we have 3 topics that you guys can choose from or choose all. This is great, for continuing summer learning or to prepare for your homeschool year. We have general science. Some topics that are included in those are like air, famous scientists and experiments, minerals, magnets. We also have another box featuring chemistry and physics. And some of those topics there are about electricity, forces, light, mirrors. And the third box is physical world and human body. And topics include bacteria, fungi, hearts and lungs, fossil, digestive system. So there's a lot to choose from, a lot to keep busy, a lot to prepare for getting a jump start on homeschooling as well. And each of those topics, each of those kits is only $39. You get 12 science kits, so it's really good price. And I think we have one more question. And let's see. Oh, okay, 2 questions.
And
So
Shirley, also in addition to that, it's also the same for the Magic School Bus. So the Magic School Bus, it's also a closeout sale for 12 kits for $39.
correct. The Magic School Bus is also on sale for $39 as well. And that has its own topics as well. Can we pull that up? That's 1 year in one box as well. So you get 12 kits in one shipping for $39. And some of the topics include our acids and bases, magnets, volcanoes, weather stations. So many topics. It's endless learning for sure. So yes. And we also have limited quantities as well too. So be sure to place your order as well. And like I mentioned earlier, the webinar is recorded. So we will send you a follow-up email with the link to the recorded webinar. And I just wanted to thank Esther for joining us today. We really appreciate you. And of course, we've learned a lot today. So we really appreciate your time taking out.
Absolutely, my pleasure.
Thanks. So we hope everybody has a great day, and we'll see you guys again soon. Thank you for joining us today.
Thank
Yes,
you.
thank you.
Bye.
Bye.